So what we have taken here is first we will take a maximum distance, that will our row plus column plus 1, and another will take our distance. So why we are taking the distance is that we have the grid one, right? We have grid. Let's suppose we have this is grid. Another we will take our distance. Okay. So if this position contains what 1, let's suppose what we will take, if this position will contain 1, then what we will do, we will update this one into 0, right? So as you can see here, so grid at I and j, if we have 1, then we will do 0, and if not, then we will find the minimum distance between both, and then we will add into the queue, onto the you can say distance. Okay, let me clean this one, then we'll. Okay, so now understand the second approach, that is the dynamic programming approach, right? So uh, for this approach, what we will do, for uh, every water cells, we need the distance to the nearest land cell, and we can reach a cell from any of the 4 direction: up, down, left, and right. So the minimum distance from any cell could be written as a minimum distance for all the cell, right? These 4 direction will do, and then we will do plus 1, and and also if we will need to check all the 4 directions, right? So what we will do, we'll take the central institution, we will understand that the dynamic programming we have to use, right? And so that we will try to find the answer for a cell using the distance of the cell that we have already calculated. And to find the calculated distance for a cell, we need to find the minimum distance of all the neighbor cells. And the main catch, we will find that we cannot have the minimum distance of all the neighbors, right, in a single traversal. So to do that, we have to traverse from top down to bottom right, right? Let's suppose what I'm talking about, if we have this grid, okay, if we have this grid, okay, so we have to go from here to this direction, right? And next, this is the first pass we'll have, right? And the second pass we have to go from here to here, right? So this is the catch we have, right? So what we have to do, we have to go we have to traverse from top left to bottom right, and we have the minimum distance of all the upper and left cell, as those cells we have already has been traversed. And similarly, if we traverse in the reverse from bottom to left, right, bottom to left, then what will happen, we will have the minimum distance of all the cells all the cells on the right and the down directions, right? So we can say that we need two traversal to find the minimum distance for all the neighbors. And in the first traversal, we will iterate from top left to bottom right, and we'll store the minimum distance for cells using the distance of the cell in the up and left direction, right? And then we will then what we will do in the second traversal iteration, we can say a traversal from bottom right to top left, right? In the first pass is this, and the second pass we are going this, right? So we will store the minimum distance using the remaining right down direction, correct? So what we will do, first we will take one distance, right? We are taking one distance, and then we will distance is the same size as we will take as a grid, and we will store the minimum distance from any land cells. And then we will initialize this distance with the maximum distance we have, right, through the monthum distance, right? We'll do the plus 1, right? You can say rows and column plus 1 will do, and that is our monthum distance, right? Then what we'll do, we will iterate over the matrix from top left to bottom right. So this way we are going from the top to left, top to down, top down, like this one, right? And this approach we are going this traversal will go to down to top left. Okay, so in the first iteration, what we will do, we will check if the cell is a land cell, right? And that contains what, it means the cell value is 1, right? Then what we will do, we will update our distance. So if this is let me clean this one. Okay, so let's suppose we have one grid, we have like this, we have grid, and this is value is 1. So we have to take the same size of the distance, right? So if this is land, then we will update its value as 0, and that we are doing here. Next time what we will do, we will find distance d1 and d2, right? How we'll do that? See, if the cell is a land, then we are doing just updating value, right? But second is what we have to do, second thing what we have to do, if the cell is water cell, right? If the cell is this value is not 1, it is, let's suppose another is 0, right? Then what we will do, this is our water cell, right? So we have to update distance as the minimum of what we will take grid minus grid at I minus 1 and j, and grid at I and j minus 1, right? And plus 1. This we will do into our from top to bottom, right? Top left to bottom right, we will, when we'll go, then we will take. But if we'll do uh, bottom up, bottom left to top right, then we'll do grid I plus 1 will do, and j, and for the this one we'll do grid I and j plus 1. Okay, because if we'll go from, this is from top to bottom, and this is from bottom to top, right? In this we will do. So we will find our distance 1, distance 2, and we'll whatever will come minimum, that will take from the distance, and that position we will have. If this cell we have any value we have already, so we'll take next time we'll take the value there, if there value. So let's suppose we are checking 0 and 1, which one is minimum? 0 is minimum, so we'll take 0 at that position, at the distance, and we'll update it's 0. Okay, like this we will update our distance, and similarly we'll go for our, you can say from bottom to top down, and we'll find our minimum, and we'll take the minimum onto the distance, and we'll check if the answer will take one minimum value, the least value we can say, and the distance cell value, and which one is max, that will return as a answer, right? So answer, while we are returning answer here like this, because see, if the value of the answer is 0 or maximum distance, then we'll return -1, as this value simply says that matrix doesn't have any water or land cells, right? So in this approach, what we are getting here is we are going with n square time complexity, because see, why we are getting n square time complexity, because we iterate over the matrix twice from top down to bottom up, right? And in we are going twice, right? We are doing iteration, and that's why we are getting n square, right? But for the space complexity, what we are getting, we are having a matrix we already have, right? And we are taking distance, another one, that is for n square of to store the all the cells, right? Distances, and that's why space complexity is also n square. Now, if we'll talk about the space optimized dynamic programming, right? It means in the previous, what we are doing, we used to create a matrix distance, and we'll use to store the minimum distance in that one. So in this approach, what we will do, we will store the information of the minimum distance in the same grid, right? And we'll apply the same algorithm on this one, right? In the on the twice, right? First from bottom to top to bottom, and bottom to top. Okay. So similarly, if we'll find the land is there, then what we will do, we'll update our cell value as a 0, and if not, then we'll find d1 and d2, and we'll check which is minimum, that will come onto the grid. The grid value will have a 1 if minimum is coming 0, right? So we'll update the grid value as a 0, right? So we'll update our grid only, and we'll say that we'll update our value, right? Next time when you're coming to bottom to up, then we will find our d1 and d2 distance, and we'll store on what, you can say, we'll take a minimum grid, and we'll say that the answer and the grid, right? Which one is max, that will return as a answer, right? And if the answer is coming, if the value of the answer is 0 or max distance, it means we have to return -1, because we have to think that it doesn't have water or land, correct? So but in this case, what we are taking here, we are passing the two iteration, right? Two iteration we are going, but each iteration will take n square, right? and we are not taking any extra spaces, right? We are taking only you can say the given grid only. We are not taking extra space. That is space complexity is O of n, O of 1 actually, okay, and time complexity is O n square. So if you like this video, please subscribe and share this video. Thank you so much.